Hello and welcome to Electronics with Emrys. This video is a beginner's guide to an oscilloscope, and my example scope is going to be the Rigol DS1054Z, which is kind of an entry-level digital oscilloscope. I'm going to start out by talking about the general things you need to know about scopes, and then I'll move on to the specifics for the Rigol DS1054Z. So if you want to just see what this scope does and how to change settings, you can skip ahead. I'll put a timestamp up on the screen for you. With that being said, let's get started. The first thing to know about an oscilloscope is that it has one important job, and that is to show you voltages. You're going to be inputting your voltages through these ports. On this particular scope, there are 4 ports, and each one of these has a ground connection that's around the outside and a signal connection that you can see down on the inside. One really important thing to bring up early on is that this ground connection is the same between all of the ports. So just getting my multimeter out, if I touch the outside of 2 of these ports, you'll see that there is 0 resistance between those. That's an important thing to know. Another really important thing to know is that the ground connection of your scope is directly connected to those outer jacks. So whenever I look at the resistance between these, it is 0. So what does that mean for you whenever you're using a scope? So whenever you connect up any probe to a scope, then that outer connection is going to go straight to the ground pigtail. So you have to be really careful what you connect this to. And remember that whatever you connect this one to, it's also connecting every other channel to that also. So this is maybe the #1 way I've seen people damage their scopes or their projects is by hooking these up to the wrong places. So be really careful with that. Now you can see on my scope that there are colors associated with each channel, and those are also associated with what gets displayed on the screen that we'll see shortly. You can put those colors onto your probe. So I like to add those onto my probe so whenever I'm working on something, I don't get confused. So you can see I have my 2 probes for channel 1 and channel 2 hooked up with those colors already. One more thing I want to show before we actually turn on this scope is that the inputs have a particular impedance, or I should say resistance. So if we look at the pin to the shield, we're going to see 1 mega ohm on every channel. And for this particular scope, you can't change that. You're going to be stuck with 1 mega ohm all the time. Some scopes have a selectable 50 ohm mode, but this one does not. A couple things about the probes that usually come with these. They're normally selectable, so it may be hard to see this on the camera, but there's a little lever right there, and it has a 10x and a 1x on it. And some of them will have another mode that'll be like a disconnected mode, but typically you want to keep this on 10x. So there are cases where you might want to switch to 1x, but usually 10x is going to give you the best signal integrity, and that's kind of beyond the scope of this video as to why, but keep that on 10x, and then inside of your scope you're going to want to set that to also have 10x on those channels, and we'll see that in a minute. You have your ground connection. This is what's actually going to hook up to the ground, and then you have your, we call it a witch's cap. You pull back and it brings out this hook that allows you to hook up to your signals. So you can pop off that end piece, and that has the signal connection right there on the end. So those are pretty sharp, but that can be handy to be able to get into certain parts of a circuit, or you can pop this off and then you can use it kind of like a pencil to probe around to different places. Just hook this thing up to a ground on your board. Then to put it back together, we just slide this over and it'll pop into place when you push a little hard on it. You can hear it snap. Now, even though the inside of this has a 1 mega ohm termination, whenever this is set to 10x mode, it has a 9 mega ohm resistor in here. So it's actually going to have a total of 10 mega ohms of resistance from the end of this to the scope. So whatever you're measuring is going to get loaded with 10 mega ohms typically in this mode. So you got to remember that whenever you're measuring anything, whether it's a scope or anything else, you're going to be modifying that circuit by attaching something to it. So you got to keep that in mind. Most of the time, a high impedance probe like this is not going to cause much effect. But if you're measuring something that's higher frequency, for example, in the hundreds of megahertz or near 100 megahertz, this can start to cause issues with that signal. Or if you have really fast edges on a signal, you might just start to see those get attenuated and rounded out a bit by a probe like this. Before we get into figuring out what all of these different things mean, I want to show you how to compensate a probe, so let's start there. Dang, I don't have my screwdriver. I'll be right back. In order to compensate a probe, the first thing you need to do is to have a consistent signal to hook this up to. And fortunately, the majority of scopes, in fact, every scope I've ever used, has a compensation signal set up already. So you just hook up the ground to the bottom tab over here, and the end of your witch's cap to the top signal there. And now you can see that I have a waveform showing up on my screen. If the signal is going off your screen vertically like this, then you can adjust it by turning this knob. You just need to make sure that you've selected channel 1, and then you can go in and adjust. Now you can see at the bottom, I'm adjusting in very small amounts. You may not be able to read it on the screen right now. Whenever I adjust this, it's going 205, 210, 215 millivolts. So if you're in that mode, you can press on this knob and it'll change from fine to coarse mode, and then we can adjust it in larger increments. So now, there we go. I've got that signal where I can see it pretty well. I'm going to go ahead and take it up one more so that it takes up most of the screen. And then I want to adjust this in the horizontal range where I'm getting about 1 period on the screen. So that's this knob, and we're just going to turn that until we get about 1 period on the screen. So now we can see it pretty well. And on this particular scope, the compensation is on the end of the probe. Not all scopes are like this. Sometimes they have the compensation up here at the other end of the probe. But basically, you just need a small screwdriver, and you can start to adjust the compensation by just turning this screw. And you can see up here that the waveform shape is going to change as you turn that screw. So it'll either be too high or too low, depending on which way your compensation is off. And you just want to adjust that until you get about a square wave. You want to get it as nice looking as possible. The shape of the wave here is going to significantly impact your measurement capabilities and what exactly you're going to get out of your scope. So now that we've compensated our probe, we know that it is working the way we expect it to. I want to show something with this that is not really a normal use of an oscilloscope, but I just want to show it because technically this is a voltage meter, right? So we can actually measure simple things like batteries, just DC voltage. So I'm just going to connect up the negative end of this to the negative end of my battery and the positive end to the positive end. And now you can see on my screen it's showing 0. And that's because I have AC coupled this input, and you can see it up here in my settings. Let's zoom in a little bit and you can see it. I'm AC coupled right now. So what I want to do is change that coupling mode down to DC. And now you can see that the signal has gone off the top of the screen. In order to get that back, we're just going to have to adjust the voltage view. So right now I'm getting 500 millivolts per division, so I can only get 2 volts in those 4 divisions. So let's adjust this because it's a 9-volt battery. So now I've got it at 5 volts per division, and you can see that I've got 5 here and then about 5 there, but not quite 5, so we have 9 volts. It's a brand new battery, so it's about 9.6, pretty close to 10 volts. Even though I wouldn't usually use a scope to measure a DC signal like this, it is important to understand the 2 different types of coupling that you can get. Because if you're in DC mode, you're going to see an offset if you have any DC change in a signal. If you only want to see AC waveforms, for example, if you're working in audio, then you're going to want to change this to AC. Now the third mode, called ground, literally connects the input to ground, so you will never get a signal out here. And I can show an example of that real quick. Just by hooking up to our compensation signal again, you can see that we don't get a signal now. If I switch this over to DC, I have a signal. If I set it to AC, I have a signal. And you notice that whenever I'm in AC, the signal is stable here, and whenever I'm in DC, the signal is not. That has to do with the triggering. So let's go ahead and look at triggering. So before we do anything else on this scope, I want to show generally where everything is. So on the left-hand side, these are your measurement buttons. We'll get to those a little later. On the right-hand side, these are the main menu buttons. So each of these buttons associates with one of the things on the screen. So this is not a touch screen. You have to actually hit these buttons to get to these things. There's also this knob, and that knob is going to be controlling whatever thing you have currently set on the screen. If you don't have anything, it should adjust the intensity of the screen. So you can turn it one way to make your, sorry, not the screen, the signal. But you turn it one way to make that less intense, and you turn it the other way to make it more intense. So I usually keep it in the middle. And then we have menu items up here. So these are kind of system menus for different things. You've got your channels right here. This is the vertical control. So, you know, if we're looking at channel 1, which is the one I have connected right now, I'm going to turn off channel 2 here. But with channel 1, these are all the menu items for channel 1. And that brings up my channel 1 signal, which is yellow. And you can see that I've connected up the yellow plastic here so that it matches up whenever I'm measuring stuff. That's very handy. And whenever we measure a signal here, let's go ahead and hook up to our calibration signal. We can adjust this, and now we can see, need to go in and change my trigger to channel 1. So now that'll get it to trigger correctly. And channel 1 I currently have set to AC coupling, so that's going to be oscillating around 0. But if I change that to a DC coupling, we will see that that signal has a 0 level that is at 0 volts, and the upper level is at a higher level. So now if your signal is going off the top of the screen and you want to bring it down, all you need to do is use this knob to adjust it back down, and you'll see on the left side that little marker, that's your ground marker for channel 1, and each channel will get its own little marker. So I bring that on down, and then you can see that the position, it says negative 1.39. I know you probably can't read that, but I want to go ahead and bring that down to 1.5. So we're going to go negative 1.5. I like to keep it at nice round numbers, and that way I'm able to easily tell, because I'm on a 500 millivolt per division setup here. So that means I've got 1, 2, 3, 4, 5, 6 divisions. And that means I've got a peak-to-peak voltage of 3 volts, which is also being measured down here because I have previously selected those measurements. So that's what these are for. That's all of your different channels. If you're going to plug in other channels, you can just turn those on by pressing the button once on that. It'll turn it on. Pressing again turns it off. You have the math menu in here, so if you want to do some math and go, like for example, if you want to take channel 1 and subtract channel 2 from it and get a third plot from that, you can use the math menu for that. This next section is your time scale. So this is basically how you're going to adjust the time of everything. Right now it's jumping around a lot because I don't have my trigger level set. So you can see at the bottom that orange arrow is pointing at the very bottom of the waveform. If I adjust that up a little bit, now it's going to trigger on a rising edge because I have it set for a rising edge, and it's going to show me that waveform nicely and keep it very stable on my screen. Now, if you wanted to look at this, so if I wanted to stop this while it's running and I just wanted to see what one waveform looked like, I can just press this run stop button and it'll stop. And now I can see what it looks like what it's seeing right now. And it seems that it's got a bunch of overlapping waveforms. So that's not very helpful to me. So I'm going to go ahead and hit run again. Now, something you can do if you've got kind of a mess going on and you don't know what things are supposed to be set to, you can try pressing auto and see if it'll automatically detect your waveform and get everything set up for you. So for a lot of waveforms, that is a good way to get started. So it's automatically set my time scale to 200 microseconds per division. It's automatically set my vertical level to 500 millivolts per division. So it's given me a pretty good waveform here without any effort on my part. You can also press clear to clear out what's on the screen, but that doesn't work while it's running. So you're going to have to hit run stop and then hit clear to clear out the waveform. So that's basically just clearing the data off the screen. Going back to run. So then, assuming you have everything set up correctly, whenever you press single, that will grab a single capture. So that's going to trigger exactly once. You get one waveform of data, and that can be very handy for transient signals. So we're going to turn that back on to run. And now you can see on the right side in my trigger area, so this is the trigger menu area. I'm currently on auto trigger. You can switch it into normal mode or single mode. So now single is just going to put us into that same single mode right there. And I really don't know what the difference is between auto and normal, because I think normal acts just like auto. So that's something I may want to look up later. But generally speaking, I would tell you to leave this in auto. You don't really need to change it off that. Usually the things you're going to be changing are going to be the level of the trigger. So where exactly do you want to trigger from on your waveform? And then adjusting in the menu, you can change whether you want to be rising edge or falling edge or both. And you can switch which channel it's coming in from, and then you can also go to other modes. So for example, if I wanted to trigger off of a particular pulse, I could set that. Or if I wanted a certain slope of the waveform, then you could do that. So there's a whole bunch of different settings in here. You could definitely play around with that. I'm not going to do that all in this beginner video. That would take forever, and I don't even know all the settings in this thing. So, okay, so now that we've seen basically what all of this stuff does, generally speaking, besides there's a help button. You can press help and get into their help system to see some useful information. You can also press the print screen button over here, and it'll tell you in here in the help, because I already turned that on. So that does a quick print. So basically, if you have a USB drive in here and you hit print, it'll print out the screen contents to that USB drive. Very handy if you're wanting to capture your waveforms. And turn off the help there. Now on the left-hand side, we have our measure menu. So this is kind of a quick menu. So you go over here, and if I want to add the period of this waveform, I just press that, and it'll pop up at the bottom with the period of 1 millisecond. And now I can also go to the top right, and there's a measure menu here. So now I've got measure on the left for the quick measurements, and on the right I have more details. So I can choose which channel do I want to measure from. So I've got channel 1 selected right now, but I could go to any of the others or the math function. Then I can choose which channel my counter is running off of. So right now it's channel 2. If I go to channel 1, then you can see that my channel, or my counter up here, is now reading a number. So it may be hard to see. Let me try to zoom in here. So you see that 1 kilohertz. Now that is a hardware counter. So that's pretty cool, because this thing has got an internal chip that's dedicated to counting the pulses here. And that's going to tell you what your frequency is of a digital signal. So pretty handy to have. You can also do a software frequency over here. Let's zoom back out. You can also do a software frequency here, and that's set up at the bottom. Frequency is 1.00 kilohertz, and you can see this one's a bit more accurate, going out 5 decimal points. But if you don't want to see the counter, you can also turn that off here. Clear up a little bit of screen. Now, if you don't want to have these measurements here, or if you want to, for some reason, reset them, you can go into the clear menu and just start deleting them out. And you can see every time I press recover, it brings back that particular measurement, and you can press delete again to get rid of it. Now there's a kind of a cool feature here called all measure. If you turn that on, you can turn it on for channel 1, turn off channel 2, because I'm not using channel 2. And then we can go and turn on the measure all feature, and you'll see all kinds of measurements that pop up here. This can be really handy if you just want to get some quick information without having to go in and choose all of the individual measurements. I kind of like this for being able to just quickly look at the features of a waveform. Also, over on the left for this menu here, you can switch between horizontal and vertical measurements. And then each of these has multiple pages, so you can see those dots there, and at the bottom there's these arrows that let you switch between different pages of measurements that are available. And really, I think that's it for a beginner's guide. If there's anything that you feel like I left out or anything that you want to, hear more about, feel free to leave it in the comments. I'll be happy to make another one of these to help you out. If you've made it to the end of this video, I want to say thank you very much for watching, and I hope you have a great day.